Today we're going to graph linear equations. Put the date on your paper and the page number. So a linear equation starts off as y equals negative 2x plus 4. It's the graph of a straight line. It's easy to remember this because in linear, the word line is there. So I like to pick any values for the value of x in order to get started. And you'll see that the second column says f of x. It's the same thing as a y. So now I substitute all of my x values into the equation. So negative 2 times negative 2 plus 4. So that will give me 8. And I can graph the ordered pair, negative 2, positive 8. And I continue doing this. Negative 2 times negative 1 is positive 2, plus 4 is 6. Negative 2 times 0 plus 4 is 4. And you start to see the pattern that the values are going down by 2. So the next value would be 2, and the next would be 0. So now I have a straight line, and I'm going to use my straight edge to connect the dots, put arrows at either end, and label it with the equation y equals negative 2x plus 4. The last thing that this question asks us is the ordered pair 3, negative 3 a solution of this linear equation. So what I'm going to do is substitute the negative 3 in for y, the positive 3 in for x, and do like a check of a solution. Does negative 3 equal negative 6 plus 4? And it absolutely does not. So the answer to our question is no. So let's try this again with another example. We have y equals negative 3x minus 4. Let's pick some different values this time. Let's pick 4, 3, 0, negative 1, and negative 2. So negative 3 times 4 is negative 12, minus 4 is negative 16. Now we picked these values not knowing where they were going to fall on the graph, but 4, negative 16 is going to be somewheres way down there off of our graph. So we have negative 3 times 3 is negative 9, minus 14 is negative 13. Again, way down off of our graph. We have negative 3 times 0 is 0, minus 4 is negative 4. This one has made it onto our graph, and it is right here. Negative 3 times negative 1 is positive 3, minus 4 is negative 1. So we have negative 1, which is here. And then we have negative 3 times negative 2, which is 6. 6 minus 4 is 2. So we have negative 2, positive 2. And so we would connect our dots with a straight edge and label the graph with the equation. This equation, example number 3, is y equals 1/2 x plus 5. And because of the 1/2, I don't want to get fraction answers. I'm going to use multiples of 2. So I'm going to start with negative 4, negative 2, 0, 2, and 4. And I'm using those values because they are multiples of the denominator. And so now I won't get a fraction of 2/3 or something that I have to add with 5. I have 1/2 times -4, which is -2, plus 5 is +3. I have 1/2 times -2, which is -1, plus 5 is 4. 1/2 times 0 is 0, plus 5 is 5, and you can see the pattern is going up by 1. So this must be 6 and 7. And so now I can plot my ordered pairs, -4, +3, -2, +4. I have 0, 5. I have 2, 6, and 4, 7. And so I connect my dots with my straight edge, putting arrows, and then writing the equation y equals 1/2 x plus 5. And down at the bottom it asks me, is the ordered pair 0, 5 a solution of the linear equation? And it very well is. It's right in our table of values here, but we can also do a guess and check by doing the 5 for y equals 1/2 times the x value, which they're telling me is 0, and does the equation check. And yes, 5 is equal to 0 plus 5, and so we would say yes, it is a solution. For example number 4, we have something that I like to call a special line, y equals 10. That means for all the y values, and our tables are always set up with f of x, which just means that it's a function of x, all the y values are 10, every single one of them. And again, for the x values, I can just continue to choose anything I want, no rhyme or reason, no specific order, because every single value for y is equal to 10. So I go over 5, up 10, I go over 3, up 10, back 1, up 10, 0, 10, and 2, 10. And you notice that it makes a special line because it is a horizontal line. An easier line to graph, y equals 10. It also means that it crosses the y-axis at the value of 10. Example number 5 is the opposite. It's not y equals -3, it's x equals -3. So that means that all of these values here are -3. Every single one. And now we're going to kind of reverse our thinking and put anything we want in the y column. Any values will work. And this line is going to cross the x-axis at -3, which makes it a vertical line. Crosses the x-axis at -3.